This is a game of snakes and ladders made using Scratch. Each player rolls the dice, moves forward that number of spaces. If they're at the bottom of a ladder, they climb to the top, and if they're at the top of a snake, they slide down to the bottom. If they roll a 6, they get another roll. This repeats until one player has reached square 100 and they win. However, you may have noticed these strange counters over here. The top one shows the chance that the cat will win. In the current position, the cat is one square ahead, so the cat has a 52% chance of winning the game. The bear, on the other hand, has a 48% chance of winning the game. Because of how Snakes and Ladders works, one player will always win. There are no draws, and every game ends eventually. So these two percentages will always sum to 100%. This is how you can build these counters yourself, and a similar technique can be applied to. When the project starts, first a lot of variables are initialized. Then the game is started. Immediately, at the start of the project, all of these, the cat and the bear are off to the side of the board. They start at the equivalent of square 0. Then they roll onto the board. Then this dice, when it is clicked, it sets an animation variable to 1. This stops another dice from being triggered when one is currently rolling and the characters are moving. This keeps the game structured. Then an animation is cycled, and then it switches to a random number from 1 through 6. Once then this text over here is set, and there's tons of costumes for each character and each roll number. So there's a total of 12 costumes as well as ones for each of them winning. As you can see, it's stated that when a character rolls 6, it rolls again. Then the players are moved, as you can see with this move player broadcast. And in each move player, first it's checked to ensure it's the current player's turn. The cat will only move if it is the cat's turn, which in this case, since the cat is player 1 and moves before the bear, it's if turn equals 1. Then whatever was rolled, whether it was a 5 or in this case a 6, that number is added to the current player's square number. Then we have this line of code. This ensures that if the player is at like 99 and they roll a 5, instead of ending off at some erroneous square like 104, they just go to square 100 and then they can win, as you can see here. Then we glide to some weird coordinates. Now, the thing is, this cat is just a sprite, and this board is just a backdrop. So by default, obviously, I can't just tell the cat to move to a specific square number. So what you need to do is make an array of x positions and y positions. You have to manually go one by one, adding x and y positions for each of the squares. So for square 1, you have to go to x2, negative 216, negative 156, and for every single one of the 100 squares on the board, there is an exact x and y position to go to. That is how the sprite knows to move exactly where based on what square it's supposed to be on. Then we have the ladders and snakes. This is what makes the name, snakes and ladders. Now, how it works is that the start of a ladder is at its bottom and the end of a ladder is at its top. The start of a snake is at its head at the top, and the end of a snake is at its bottom. If you are at the start of a snake, which means the ladder's start contains your current square, you are moved to the end of that ladder. And same goes with snakes. How does the sprite know whether it's at the start or end of a ladder or start or end of a snake? Well, it's hard-coded as well. This time, instead of using x coordinates, since we already have a way of mapping square number to coordinates, now it's just written what square number it is. So in this case, we know that square number 1 is the start of a ladder, which ends at square number 38. The important part is that it's corresponding. The same element in both corresponds to the start and end of the same ladder. So as you can see, there's a ladder from 28 to 84. Then there's also one from 80 to 100. Same goes with the snakes, but this time, as you can see, instead of the number starting small and increasing, it's large and going down, because the snakes obviously set you backward. Once the character has been adjusted for their new position based on after climbing a ladder or sliding down a snake, they have to glide to their new position. Once the cat's turn is over, as long as the cat didn't roll a 6, it's now the bear's turn. If the cat did roll a 6, it's still the cat's turn, so we don't change the turn number. This wait 2 seconds here, it's just that apparently Scratch, the glide 1 seconds, it doesn't stop for 1 second until it's done gliding, but it just glides and then starts moving on to the code. So we need to wait 2 seconds to keep everything structured. Then the animation is set to 0 so the next player can click the dice button again to roll again. This repeats until eventually one of these is called. So notice how we have wait until bear square is 100, which in this case is player 2 square because the bear is always player 2. Then the game is ending. And in once the cat reaches square 100, we also broadcast this end game broadcast. Once the end game broadcast is done, first of all, the dice is locked. Since the animation is forever set to 1, it means that clicking the dice button will no longer do anything. That's essential to stop people from rolling the dice after the game is over. Then the text will announce who has won, depending on who is at square 100. That is the base game. The more complicated part is these win percentages. As you can see, as I roll the dice, these win percentages will change. When someone lands on a ladder, their win percentage will go way up, and when someone lands on a snake, their win percentage just goes down. As you can see, the cat's win percentage is currently 50%, and now it's 49% because it missed a ladder here. Since the bear now has rolled a 6, which is a big roll, its win percentage has gone up, and it rolls again. This keeps going. But how does the program know what the chance of the cat winning or the chance of the bear winning is? This is a method called the Monte Carlo method. It's similar to something called Monte Carlo tree search. It basically involves a bunch of random trials. You play the game out randomly to its conclusion, and you see who wins, and you repeat to see who wins more often in a given position, which is exactly what we're trying to find out here. So we basically simulate a lot of games. Whatever the current position is, we simulate the player 1 square and the player 2 square and the turn to whatever they are. This basically sets up the current position. Then until someone in our simulation is won, we basically do what the game does. Roll in a random number, bound to 100, go up ladders and down snakes, swap the turn if you didn't roll a 6, and so on. It simulates a game to its conclusion, and then once the game is done simulating, it notes down whether the cat won or whether the bear won. And this keeps going. Because even though Scratch is considered to be slow, 1,000 games can be played every second at least. This means we very quickly can tell which